Okay, so the topic of this video is just what's inside of an atom. Now, we used to think that atoms were indivisible, but about 120 years ago, we learned for the first time that an atom is made up of 3 different types of smaller particles that physicists called subatomic particles. Now, sub is just a word meaning smaller. So subatomic means smaller than the atom. Now, as I said a second ago, there are 3 types of smaller particles, subatomic particles, that work together to make up an atom. The first one is the protons. They have a charge of +1. The second is the neutrons, which are neutral. They have a charge of 0. And electrons have a charge of -1, which means that they are negative. In order to remember this, I think of protons being positive, that both begins with P, and I think of the neutrons as being neutral. So that only leaves me remembering that the electrons are negative. Have a look at the diagram on the right-hand side of your screen. This is a diagram of the 3 subatomic particles that make up the atom as a whole. Notice that the protons and the neutrons are lumped together in the center to make up the nucleus. And the electrons are occupying shells around that nucleus. Now, atoms must be neutral. That's a rule. Because protons have a charge of +1 and electrons have a charge of -1, that means that to make an atom neutral, the number of protons must be equal to the number of electrons. Take a second to copy the diagram and the labels into your notebooks. Again, take note, the protons and the neutrons are lumped together to make up the nucleus, and the electrons are arranged in shells around the outside of the nucleus. It takes a combination of the nucleus and those shells of electrons to build the atom as a whole. Now, the electrons aren't just shoved into an atom in any old way. They have to be very, very carefully arranged according to the laws of nature. Now, configuration is just a fancy word for arrangement. So electron configuration means how are the electrons arranged. Now, there's a whole host of rules for you to learn here. First of all, the shells that are closest to the nucleus are smallest, so they hold fewer electrons before they're full. Think of a tiny little car like a Barina. You can't put very many people in it before it's full. There is room for up to 2 electrons in the first shell, 8 electrons in the second shell, 8 electrons in the third shell, and up to a maximum of 18 electrons in the fourth shell. So if our first shell is a little bit like a Barina that's very small and doesn't have many seats before it's full, the fourth shell is a bit more like a small bus where there are many, many more seats and can therefore take many more passengers before it fills up. The largest atoms known to us are 7 shells. However, nobody is ever going to ask you to draw an atom larger than calcium, so you don't need to remember what happens after the 4th shell. Finally, the inside shells have to be full before electrons can start filling the outer shells. That's another rule for you. So let's put these rules together into an example. Have a look at the diagram of the atom on the right of this screen. Again, you should copy it into your notes. This is a carbon atom. It has 6 protons in its nucleus. Therefore, to make it neutral, it needs 6 electrons arranged into its shells. So 2 electrons get packed into the first shell. But that's only 2 of the 6 that we need before the first shell is full. So the remaining 4 electrons have to go into the second shell. This makes the electron configuration of a carbon atom 2 electrons in the first shell and 4 electrons in the second shell. You can illustrate this with the diagram like you see on the right-hand side of your screen. Or you can represent it with the short form that you can see there in the notes on the left-hand side. That is, the electron configuration of a carbon atom is 2, 4. Lastly, how do you know that a carbon has 6 protons, aside from me just telling you that? Well, the answer is actually pretty straightforward. The periodic table is arranged in increasing number of protons. That's the order of the periodic table. So all you have to do is find your element on the table, and its position will tell you how many protons it has. Prove this to yourself. Pull out your periodic table. Find carbon. You'll find its element number 6. That means it has 6 protons in its nucleus. And that's everything you need to know today about the structure of the atom.